Hello everyone, I am honored to briefly introduce our research, Quasi-Full-Metal mmWave Circularly Polarized Endfire Antenna with Small Cross-Section, based on SSPP. Spoof Surface Plasmon Polaritons, SSPP, a recent research focus, readily converts to leaky wave antennas with scanning or endfire beams via phase velocity control. Yet existing realizations rely on PCB and are fed by microstrip or coplanar waveguide slot line with coaxial connectors, both incompatible with millimeter waves, where waveguide interfaces dominate and dielectric loss is prohibitive. This work addresses dielectric loss and feed interface issues at millimeter wave band. Mathematical derivation treats the antenna as groove pairs fed at the origin. Setting beta equals K0 satisfies the phase coherence condition at theta equals 90 degrees. So beta almost equal to K0 generates endfire. 3-blade radiators with differing groove depths reveal that optimal depth raises endfire directivity by tuning the propagation constant, providing the phase shift required for circularly polarized endfire radiation. Quasi-circularly polarized radiation at endfire direction can be obtained by rotating the single primary blade to a proper angle. Axial ratio bandwidth is widened by adding a secondary blade, resizing blades, and optimizing their relative positions. Choke slots etched on the brass plate suppress surface waves and degrade side lobe level. A conical hilt plus 24 degrees wedge blades generates a wideband, error-tolerant waveguide to SSPP transition. The final antenna consists of an SSPP radiator, securing foam, and a brass plate. All parts of the proposed antenna are manufactured by computer numerical control with machining accuracy of plus or minus 5 micrometers. The simulated and measured results show that the proposed antenna exhibits high-efficiency circularly polarized endfire patterns within 56-65 GHz. To clarify the superiority, a comprehensive comparison is illustrated in the table. As seen, the proposed antenna has the smallest cross-section compared to other reported millimeter wave circularly polarized endfire antennas. In summary, we solve millimeter wave feeding interface issue with a standard waveguide and broadband transition structure. Eliminate dielectric loss via CNC machined air-filled metal. And deliver a broadband, high-gain, high-efficiency circularly polarized endfire antenna with smallest cross-section. Thanks for your attention.